Hey guys, welcome to Homework Help for Year 5, Term 2, Week 8. This week we only have 3 pages of homework, so that's a win for you guys. And these questions are relatively easy. So on page 6, question 1 says 2 angles of a triangle are 67, 78. What is the size of the third angle? Now we know that for any triangle, the sum of all the angles add up to 180. So I'm just gonna quickly draw that. Oh, it's a terrible triangle. I'm just gonna fix that. Okay, so imagine you got one angle is 67 degrees, another angle is 78 degrees. So what's the third angle? Well, we know that 67 plus 78 plus a third mystery angle will give you 180 degrees. All the angles always add up to that much. So let's just add these first two. And we got 67 plus 78. 7 plus 8 is 15. Carry the 1. That's 7 plus 7, that's 14. So 145. So you got 145 plus with this third unknown angle is 180. To find the third angle is to do a subtraction. We want to find a difference between 145 and 180. So you have to do 180, take away 145, and then you just have to work that out and get the answer. Alright, not too complicated. Let's do the second one. If the vertical angles of an isosceles, if the vertical angle of an isosceles triangle is 36, what is the size of the other angles? So I'm going to draw that real quick. Now, an isosceles triangles have 2 equal sides and 2 equal angles. Now it says the vertical angle, so it's just talking about the angle at the top here, which is 36. So again, we know that 36 plus some unknown angle plus the same unknown angle is equal to 180, because that's just the angle sum of a triangle. So let's just think of this as one number. Okay, when you're adding, you can just do that. 36 plus what is 180? So let's find a difference. So let's do 180 minus 36. Now this will be a 7, this will be a 10. 10 take away 6 is a 4. 7 take away 3 is a 4, and that's a 1. So then, therefore, 36 plus 144 will give me 180. And that's true. So that means that these two angles, the same angle, is add up to 144. So how do we find out each angle? 2 angles that are exactly the same add up to 144. So to find the value of one angle, we just take 144 and we half it. We divide it by 2. 14 divided by 2 is 7. 2 times 7 is 14. Take away no remainder, bring the 4 down. 4 divided by 2 is 2, so the answer is 72. That means 144 is made up of 72 degrees plus 72 degrees. So that means that each of these angles is 72 degrees. So that's the answer. It says, what is the size of the other angles? The other angles are 72 degrees each. Okay, there's your answer. Question 3 to 6. Write true or false for each of the following. A triangle with 2 equal sides is an equilateral triangle. A triangle with 2 equal sides? No, not necessarily. Okay, an equilateral triangle has 3 equal sides. But if you only have 2 equal sides, that's called an isosceles triangle, so that's not true. Okay, so equilateral has 3 equal sides. Isosceles triangle has 2 equal sides. So to say that a triangle with 2 equal sides is equilateral is false. That's That should be called isosceles, not equilateral. Question 4, the angle sum of a quadrilateral is 360. So it's saying that a four-sided shape, which is what a quadrilateral is. Quad means four. Okay, so it's a shape that has four sides, like this, something like that. And it's saying that all the angles of this shape adds up to 360. And yes, that's true. Okay, and the reason why it adds up to 360 is because a four-sided shape is actually made up of two triangles. Okay, all the angles of a triangle, right, add up to 180. And all the angles of the second triangle always add up to another 180. So 180 plus 180, 0, 8 plus 8 is 16, and that's 3. Always add up to 360. So the angle sum, the angle sum of a quadrilateral is always 360, which is true. Question 5. An angle of 92 degrees is an acute angle. Okay, well, acute angles are between 0 and all the way to 90 degrees. Anything bigger is not called an acute angle, that's called an obtuse angle. So to say 92 degrees an acute angle would be false. Question 6. Two angles of a triangle can be obtuse. Okay, so in a triangle, can two angles be obtuse? Well, think about it. If one angle is obtuse, it means that, so let's say we got three angles. Okay, so imagine we got three angles. Now we know these three angles add up to 180, right? If one angle is larger than 90 degrees, actually so that'll be, let's say 91 degrees. And let's say another angle is also obtuse, which is 91 degrees. Already, if I add these two, just these two alone, already I have 182 degrees. And then, so that means that these two, if I have two obtuse angles, it's going to add up to more than 180 degrees. So that's impossible. Like, how can that be a triangle? A triangle always has to have three angles out to 180. There's no third angle that can make it 180. So that's impossible either. So that's false. Okay. Now question 9, 7 to 9. The diagram shows a hexagon, regular hexagon within a triangle of radius 6 centimeters. Okay. So I'll just zoom in for this. So it means that from here to here is 6. That's the radius. This is called. So that's called the radius. It's the length from the center of a circle, a straight line going all the way to it hits the edge of the circle, and that's called the radius. And it says the radius is 6 centimeters. So if I can just write 6 there. Okay. Now it says, what is the angle x? Okay, so let's see. Let's see what this angle is. Well, let's continue with this line and continue with this line. Okay. How many triangles can you see inside the circle? It's basically, you got 1, 2, 3, 4, 5, 6. 6 triangles that are the same and have the same inner angle. Whoops. Okay, so meaning that this regular hexagon can be divided into 6 such triangles. 1 triangle, 2, 3, 4, 5, 6. Now we know that if I was to go all the way around, from here all the way around to here, that's a full revolution, right? That's 360 degrees. A full revolution of a circle is always 360 degrees. Okay, now 360 degrees divided into 6 equal angles. All these angles are equal to each other. They're all, because this is a regular hexagon. So when you divide the angles, they're all going to be equal. So you divide it by 6. So let's have a look. What is 360 divided by 6? The fastest way to do this question is to look at this part here and say how many 6 go into 36. Well, if you know your times tables, the answer is going to be a 6. So this will be 6, and then you got 1 0 sitting around, so we put the 0 back in, and that's 60 degrees. So that means that this is 60 degrees, that's 60 degrees, this one is 60 degrees, and so on, right? All the angles are 60 degrees. So let's just look at one of the triangles, and let's zoom into one of the triangles and see what's happening here. Okay, now all of these triangles are the same. So let's look at this top triangle. Actually, it's better. Alright, so I'm going to zoom into this top triangle. Okay. Okay. Oh, that's a good one. Okay, let's just make it look more equilateral. Alright, so now we know that this angle here is 60 degrees. Okay, now we need to find x, but we know that x, the angle x here and this angle here are both x, and the reason why is because of this. From here, this is the center of the circle O, okay? Now to go from O to here, the length here, that's the radius. Right, so that's the radius there. And from here to here is also the radius. So that's another radius there, which is, and they're both equal to 6, isn't it? These are both 6 centimeters and 6 centimeters. So what kind of triangle do we have here? We have an equilateral triangle because we have 2 equal sides, isn't it? Oh, sorry. It's an isosceles triangle. We have 2 equal sides, so therefore it's an isosceles triangle. And the angle in the middle here is 60 degrees. So we know that these two angles here, x and x, they have to be the same. So let's work out what x is. So we got 3 angles. We got x. Actually, let's put that in red. So we got x. Okay, this is angle. I'll just put a box so you know it's not means times. This is the angle x plus the angle x plus 60 degrees is equal to 180 degrees. All 3 angles must add up to 180 degrees, but at the same time these 2 angles are exactly the same. So let's think of this as 1 unit. Okay, it looks like a face now. Alright, so let me just so think of this as 1 unit. So something plus 60 is 180. So 180 minus 60 will be 120 degrees, because 120 plus 60 is 180. So therefore these 2 angles add to 120. Now to find each angle, we just divide 120 by 2 and you get 60. So that means x must be 60. There you go. And we just discovered that x is 60, so this is 60 degree and 60 degrees. And now we just found out that not only is this triangle isosceles, it's now transformed into a equilateral triangle, because all the angles are 60, and that means all of the lengths must be the same as well. So this length, the top one here, must also be 6 centimeters. What type of triangle is CDF? CDF. What is it? F? CD. Oh, okay, I see it. Alright. So let's go back to this triangle here and highlight what CDF looks like. C to D to F. It wants to know what kind of triangle this is. Okay. Well, you know, you could we know it's just a triangle, but what kind of triangle? Is it a acute triangle? Is it an obtuse triangle? Is it a right angle triangle? What, you know, is it a isosceles triangle? Well, it's not isosceles, all the sides don't look the same. Now, just imagine if I was to draw another line here and then here. Can you see that we've made a rectangle? Because remember, this is a regular hexagon, meaning that the top and bottom of the regular hexagon are parallel, and the sides are also parallel. So what kind of shape has this thing? This kind of thing? Well, either a rectangle or parallelogram. Okay, but you can see that it looks very much like a rectangle, and actually it is a rectangle. Okay, so that means this is 90 degrees and this is 90 degrees. All right, so if we have this shape that has a 90 degrees, so we call it a right angle triangle. Right angle triangle. Now, when you do further mathematics in year, I don't know, I think 8 or 9, you'll discover they'll teach you why this is a right angle triangle in circle geometry. But for now, just know that it is. Okay, I can't go into that topic right now. It's going to be a year 8, year 9 topic. Anyway, we'll move on to question 9. What is the perimeter of the regular hexagon? So they want to find the perimeter of this regular hexagon. Okay. So let me just get rid of that color there. Wait, what? What happened? Oh. Okay. Now, no, actually I'll put it back. Okay. Let's rub this out. So we found out that this is 6 centimeters. Hold on, this is 6, and this is 6, and therefore, and since this triangle is an equilateral triangle, this also must be 6. All right, so therefore that means this is 6. This is 6. All of these are 6 centimeters because they're all made up of the same triangles. They're made out of 6 equilateral triangles where everything's 6. Alright, so what's the perimeter? Well, the perimeter is just adding up all the lengths of the outside, meaning adding up all of these 6s. So how many 6s do we have? We got 6 6s. So the perimeter of the regular hexagon is 6 times 6, which equals to 36 centimeters. And you're done. Question 10 to 13. Which solid shape does each net form? So we have to imagine if we were to take these nets of a shape and we construct a shape into a 3D shape. Okay, so let's see. First one is we have 2 octagons. So we have an octagon here. Hopefully I can draw it correctly. Right, and then it's joined to another octagon there. So what kind of shape is that? Well, this is called an octagonal prism because it doesn't have a what's known as an apex. If it has an apex, it's a pyramid, but this is a prism. It doesn't have an apex. It has a point where all of the other corners join up to. And I'll show you when it gets to one of those. So it's called octagonal prism. Okay, next one is you have a circle. So imagine you have a circle like this, and this shape here can be folded, and it will look into like this. So what do we have? We have a cone. All right, let's fold this one. You have a base, which is a square. So hopefully I can draw a square. This, and then the square has 4 triangles, and they're all going toward a top point here. So if I just join that with that, maybe I should do something like that. Yeah, you can see. Whoop. See, now this is called, the base is a square, so we call it a square pyramid. because all of the corners, okay, they all connect to this one point here, and we call it the apex of the pyramid. So we have a pyramid, not a prism. Alright, next one, you have two circles and a rectangle. So imagine if I take the two circles and I lay them flat like this, and I take the rectangle and I fold it around so it connects to each side, and you have this. So what do you have? You have a cylinder. Okay, question 14. The diagram shows the net of an ordinary die. Fill in the spots on the missing faces. Opposite faces of a die add up to 7. So, opposite face up to 7. So if we fold this, so imagine if I just fold, I'm just gonna make, let me see here. So I am going to leave this as the bottom. Okay, so that's, so imagine I've got like something like this. Right. And so this is our 5 okay, and this is our 3. So what is the opposite to, so the opposite face to the 3 has to be, I'm gonna put it in blue. So the 3 and this one are opposite faces, right? So that's, so, and it says opposite faces of a dice add up to 7. So 3 plus what gives me 7? This must be 4. Which means that this also must be 4. Okay, what else we got? Okay, these two are going to be opposites. So if that's a 1, this must be what plus 1 gives me 7, this must be 6. So you have to use your imagination and see what happens when you fold it. Which faces will be opposite? Whatever the face is opposite, they have to add up to 7. And obviously there's only one left, you can figure out what that is. Okay. Next one, question 15. The top of a cylinder is sliced off as shown in the diagram. What type of net is formed from the bottom part of the cylinder? The bottom part of the cylinder. Alright. So you have a cylinder. I'm just going to redraw this cylinder. Like this. The cylinder is being cut off. Right. Now I'm going to take a pair of scissors and cut down here. Okay, and then I'll unfold this shape. This shape, and see what happens. Well, when I cut it and I so I take this point and I bring it over here. Okay, so now it's gonna unfold. So it goes up, and then it goes down like this, and this side should be the same length. Oop. This side should be the same length as that side, and this round bottom part is going to turn straight. So therefore, what shape do we have there? We have this shape here. That's the answer there. Alright. Now it says each diagram, question 16 and 18. Each diagram shows the front and top view of a solid. Name each solid. Okay, so we got the front and top view. So the front and the top. So the top looks like a square, and the front has a weird, like a shape there. So the way I can imagine it is that this is basically, it's like this. I'm thinking about like this. So top, this is the top. If you look down, you'll see like a diamond, right? Because it's a cube that's kind of like shifted to the side, so that when you look at the front, so if you're standing here and you're looking at it, right? This is the front. You will see this shape here. you'll see a shape with a line in the middle because that's the edge. And the top looks like a diamond, so therefore this must be a cube. Alright, moving on to the next page. Let me see. Now you have, what do we have here? We have what looks like this. So this is our bottom face, and you have so at the front. Oh, actually, I drew it wrong. Hold on. It's actually more like this. It's facing like this. That means that it's the back edge is actually not viewable. So when you're standing in the front, okay, you will see this shape here. This is the front, and this is the top. So top looking down, you will see, yeah, you will see that. You'll see this part here. Okay, it's kind of hard to imagine, but technically this is called a triangular pyramid. It's in the shape of a pyramid. It's got all the points joined to the apex at the top there. Alright, this one, imagine, top looking down. Okay, so top, this is the top, this is the front. It's a very weird kind of shape. I think the front is drawn backwards because it should be the front. That makes no sense. The front should be drawn like this. Okay, so this is a mistake I think by the question. It should be like this. Okay, so the front, if you look at the front, it looks like this, and if you look at the top, it looks like a circle. So there's a top here, but the front looks like a triangle. So what is that? That's just a cone. Alright, question 19 and 20 is, it says 27 small cubes have been glued together to make one larger cube as shown in the diagram. The large cube is then painted blue all over. How many small cubes will have two sides painted? Well, let's have a look at this cube, and let's look at two. If you paint this whole thing in blue, okay, which two sides are painted? Well, let's look at this corner cube here. How many sides did this corner get painted? You got one top and side there and side there. You got three sides painted. The other three sides are hidden inside the cube, so you can't paint those faces because they're inside it. So this only has three sides painted, so it can't be the corners. How about the ones there? These guys only have one side, one face painted, right? So it can't be those guys. So it has to be these side edges here. These guys have two face painted. So we need to count how many of those edges, and that tells you how many of those cubes out of 27 has two sides painted. So we got one of them here. There's one cube. We got 2 cube, 3 cube, 4 cube. On the other side, 5, 6, 7, 8. Okay, and then you have 5, 6. I'm going to put one here, 7 and 8 there. Well, no, hold on. Down here, 7, 8. Okay, and then you have these side ones, 9, 10, 11, and 12. So if you count them, there's actually 12 cubes that has two sides painted. Now it says no sides painted. Well, there's only actually one cube with no sides painted, and that is the core. Okay, it's in the very middle. Okay, so imagine here's your cube. It's the very center one. It's in the very middle there. It's hidden. It has no face revealed. All of its faces are hidden. So therefore, there's only one face. One cube. Alright, next one, question 21. What is the angle between 430? Okay, so let's just draw a real quick. So we know that the angle inside of here, that goes from, let's say, 12 all the way around to 12, that's 360. So 360 degrees inside there. Now 360 is divided into 12 equal sections. 12 equal sections, okay? So how much is each section? So we take 360 divided by 12, and the fastest way to do that is we say, okay, how many 12s go into 36? And we know the answer is 3. So therefore, 360 divided by 12 is 3 with a 0, that's 30 degrees. So what that means is that each of these angles is 30 degrees. Okay, 30 degrees each. So for the hand to move from one hour to the next is actually moving only 30 degrees. So that's what it means. So now we have the time to be 4:30. So I'm going to put that in black. So 4:30. So here's the thing that the long hand is pointing towards a 6. And the short hand is pointing to between the 4 and the 5. There we go. So they say, what is the acute angle between them? So what is this angle that is between it? Okay, we know that this one, nope, I want it to be blue. This angle, the angle between each hour is 30 degrees. This is 30 degrees. Now, this is another 30 degrees, but we only have halfway. So that means that this angle here must be 15 degrees. So what is the angle, the total angle between them two is, we say 30 degrees plus 15 degrees, and that gives us, you figure it out. Alright, question 22. What is the size of the angle of an equilateral triangle? What is the size of the angle of equilateral triangle? So let's draw an equilateral triangle. Hopefully it looks good. Could be better. But alright, we'll just make it like this. Doesn't actually snap into equilateral triangle, but that's okay. Looks pretty good. There you go. Equilateral triangles have all the sides to be the same length and all the angles to be the same angle, and each angle is 60 degrees. 60 plus 60 plus 60 is 180. So one size of one of the angles is 60 degrees. Done. Question 23 says, find the fourth angle of a quadrilateral triangle given the other three are 45. So imagine you have some quadrilateral shape here, and one angle is 45 degrees, one angle is 70 degrees, 120 degrees, and it's asking what is the third angle. So we have to figure it out. What is this the fourth angle? So we know that 120 plus 70 degrees plus 45 degrees plus with this unknown mystery angle is equal to, all the angles add up to 360 degrees. Or whenever you have a four side shape, all the angles always add up to 360. So let's add up these three first. Let me see, we got 120. This will be 5. 2 plus 7 is 9. 9 plus 4 is 13. Carry the 1, and this will be 235. So we have 235 degrees plus with a mystery angle is equal to 360 degrees. How do we find the mystery angle? Well, just do subtraction. We want to find the difference, okay, between 360 and 235. So we need to do 360 take away 235. 5. And you get subtraction, you get the answer. So work it out. It says, question 24, a solid is formed by cutting all the corners of a cube shown. Find the number of sides of the new solid. So they want the number of sides, which is the number of faces. How many faces does a cube have? A cube normally has 6 faces. Okay, top, bottom, left, right, front, back. Now, if we cut the corners, every time we cut a corner, we create a new face. That's a new face there. We cut another corner, we make another new face. How many corners does a cube have? It has 1, 2, 3, 4, 5, 6, 7, 8. It's got 8 faces. So when you if you cut 8 corners, you're gonna have 8 new faces. So it's gonna add with 8 new faces. So how much face do we have altogether? 6 plus 8, 14 faces. And there's your answer. Alright, multiple choice question 1. It says, what is the value of this one? Okay, you have to do bottom maths, so you gotta do this one, have to be done first. 2 plus 3, that gives you 5. So now you have 2 plus 3 times 5. Okay, so brackets have to be done first, so that's why it's 5. So now you just do multiply, it has to be done next. That's more important than plus, right? So therefore we do 2 plus with 3 times 5 is 15, and then you can get 17 as your answer. Next one says 2 circles fit exactly into a rectangle. The radius of one of the circle is 6 centimeters. Find the area of the rectangle in centimeters squared. So this one actually, it's on the next page. So you gotta go to the next page. And it says, and there's your 2 circles in the rectangle, and it says the radius is 6. So the radius is from the center of the circle, drawing a straight line to the edge of the circle, and that's 6 centimeters. This is called the radius. So let me zoom in. It's called the radius, and it's 6 centimeters. Let me double check. Is it 6? Yeah, it says 6 centimeters. All right. Oops. All right. So if that's 6, I'm just gonna rub this part out now. If that's 6, then that means that if we draw a straight line from there to there, we know that from here to here is also another 6. From here to here is a 6, and then from there to there is another 6. So that means the total length of this rectangle is 4 lots of 6, which is 24. 4 times 6 is 24 centimeters. And how many centimeters is it wide for this rectangle? Well, it's made up of it's made up of 2 radiuses. It's 6 and 6. It's made up of 12. So now we just have to find the area of this rectangle. We know that it's 12 centimeters wide and 24 centimeters long. So area is equal to 12 times 24. So you work that out and you get the answer. Question 3, 4, 5, 6, 7 refer to the sequence of numbers 1, 2, 4, 8, 16, where each number is twice the number before it. So for example, 2 is twice of 1. This is 2 times 1. 4 is 2 times 2. 8 is 2 times 4. 16 is 2 times 8, and so on. Okay, no problem. Let's use this. It says where okay. It says question 3. The 7th number in this sequence will be what? So you have to work it out. This is the first number. Let me put these ones in. Okay, so this is the first, second, this is the third number, 4th, 5th, 6th, 7th. So what will be the 7th number? Just double it. Well, to go for the next number, we just have to double it, because we're just doubling, right? This will be 32, and then double that, double 32, you get 64. So therefore the first one will be 64. The 7th number should be 64. The sum of the first 6 numbers in the sequence. Well, what's the first 6 numbers? The first 6 numbers will be these ones here, right? So you're going to do, they want the sum, they want a total, so you have to add them all up. So we got that 1 plus 2 plus 4 plus 8 plus 16 and plus 32. That's the sum of the first 6 numbers. So you work it out and you can get the answer. Question 5. The numbers are placed in a table shown. What number will be in the second column in row number 5? So I'm going to redraw this table. Now we have the numbers 1 and 2. So each number is doubling the next. So then we times 2 by, we double 2, we get 4. Double 4, you get 8. Double 8, you get 16. Okay, and so on. And now it says, let me see, what number will be in the second column in row number 5? So this is the first row, second row, third row, fourth row, fifth row, sixth row, seventh row, eighth row, ninth row. So the fifth row, row number 5 and second column. So it's looking at this one. They want this number. Okay, well let's just keep doubling it until we get that number. Alright. Oh, so we got, so 16, you double 16, you times it by 2, you get 32. Double 32, you get 64. Double 64, you get 128. Double 128 is 256. Now if you double 256, what do you get? You're gonna have to, I'll just do it. Double that, you get 512. Okay, so the answer would be 512. In the table in question 5, what would you get by subtracting the numbers in row 7? Okay, we need to get to row 7. So double 512, you get 1024. Double that, you get 2048. Double that, you get 4096. Now if you double that, you're going to get 8000 something. Let me just double check. 4096 times it by 2. 2 times 6 is 12. Carry the 1. 2 times 9 is 18. Plus 1 is 19. 2 times 0 is 0. Plus 1 is 1. 2 times 4 is 8. So you're going to get 8192. Alright. So, what would you get by subtracting 2 numbers? So if you take the big number, which is 8192, and you subtract the 4096, what do you get? You work it out. You tell me. Alright, question 7. Which will be the first number in this sequence which is greater than 17,000? Okay, so we want to. So if we keep going, they say what is the first number to be bigger than 17,000? So let's just find out. Okay, so I just fixed up a couple of my mistakes. I multiplied wrong, so the answer should be this one here. This is the correct answer. And I need to fix these up. So 16384. And then when you double that, you will get 32768. So this will be 68. Okay. Alright. Wait, 3, 8. Yeah, okay. Everything's good. Okay. Silly mistakes. My mistake. Now, next one says, question 8 says, what fraction is a fortnight of a year? What fraction? So, a fortnight, and now it says, what fraction is a fortnight of a year? So, the way we do these questions is you have to understand is and of. Is always goes on top of the fraction, of always goes on the bottom of the fraction. So, is a fortnight. So, is a fortnight, so we put fortnight on the top. Fortnight means 2 weeks, not the game Fortnite, okay? And of a year, so the year is at the bottom because of a year. So the year goes to the bottom. Now this means 2 weeks. So you can't compare, you can't do this, we can't compare them yet. We need to make them the same amount. So let's make them both into weeks. Fortnight is 2 weeks and a year is 52 weeks. So that's just 2 out of 52, and we simplify that, divide top and bottom by 2, you get 1 out of 26, which is D. Find the value of 2/3 of 24 and add it to 3/5 of 45. So 2/3 of 24, of means times, so 2/3 times 24, and add it to, so that whole thing will add to 3/5 of 45 means times 45. So according to this, if you look at this, you have to do the bottom math, so which means you got to do times first. These two must be done first, so let's do them. Let's focus on this one first. 2/3 times 24. Now 24 is a whole number, so we have to put it over 1 so we can multiply. That's the way we multiply fractions, right? Now when you multiply a fraction, the special thing you can do is that you can simplify while multiplying. So we can look at the 2 and the 3. Remember, it has to be top and bottom. So 2 and 3, can we simplify that? No, they're both prime numbers. Can we do 2 and 1? Nope. Can we do 3 and 24? Yes. They can both be divisible by 3. Now what about 2 and 24? Can we do that? Sure, but not really. Okay, and it looks like you can, but you can't. Because they're both on the top. You cannot simplify top and top. It has to be top and bottom, so that means 3 and 24 can be simplified. So we divide them both by 3. Divided by 3 you get 1. Divided by 3 you get 8. Okay, so really the question comes down to 2/1 times it by 8/1. And that gives you 16/1. Just multiply the numbers across now. And so 16/1, now 16/1 is just a whole number because it's over 1. So that just turns into 16. Okay, let's focus on the second one. So now we can put the 45/1 because we want to turn into a fraction. Now we simplify. We look at the 5 and the 45. We can divide them both by 5. 5 divided by 5 is 1. 45 divided by 5 is 9. So now you have 3/1 times it by 9/1. So 3 times 9 is 27 over 1 times 1, which is 1. Just times them across. 27/1 is just equal to 27. So that this whole thing turns into 27. So now we just do an addition. It says that plus that. So add them together. So do 16 plus 27. You can work out the answer yourself. Alright, next. It says, what is 1 out of 40 expressed as a percentage? Okay, so let's have a look here. To do percentage, the method for finding percentage when you're given a fraction is we try to make the bottom number into 100 out of 100. At the moment it's out of 40, so not going to be very helpful. Now whatever the number you get for the top, they'll give you the percentage. So let's pretend it was 7 out of 100. Let's say this changes into 7 out of 100, right? That would mean it's 7%. If it was 8 out of 100, it would be 8%. So whatever the number on top is your actual percentage. Okay. So now, can I go from 40 to 100 using multiply and divide? No. It's yes you can, but it's pretty hard. So you can't do it easily. So let's go one step before that. How do I go from 40 to what number can turn into 100? Okay, we can make it into 20. So I can turn a 40 into a 20 using division, and then I can turn a 20 into 100 using a times. Now 40 divided by what? 40 divided by what number gives me 20? Well, divided by 2, which means the top number must also be divided by 2. And then how do I go from 20 to 100? I must multiply by 5, which means the top number must also multiply by 5. Oh, by the way, it's not 7. I was just making that up. Okay, so let's see. What's 1 divided by 2? That's just a half, right? Or you can think of 0.5. So you could say you could put either a half here, or you can put 0.5. It's the same thing. And then you just have to multiply that a half or 0.5 by 5. So what's 0.5 times it by 5? 5 times 5 is 25, and decimal gets to be there. So this is 2.5 out of 100. Okay, or you could just, or if you decide to leave this as a half, let's say you wanted to leave as a fraction a half. Okay, what's a half times 5? Well, 5 is over 1, so that's 5 over 2, which is this is improper fraction, change to mixed numeral, you get 2.5. So you could say that's 0.5, or you could say 2.5 out of 100, which is, you could say that's either 2.5%, or you could say 2.5%. Okay, either way, yeah, they're both correct answers. So the answer has to be C, obviously. Okay, and I think that's the last of them. Okay, hope that helps.